Okay, let's get started. We're good? Hello, everybody. I know this is the last session of the day, so I'll keep this energetic and exciting, I promise. So my name is Rick Viscomi. I am a developer programs engineer at Google. What that means is my day-to-day job is to work with developers, both inside of Google and externally, to improve the state of the web. And I work on two main projects that have a web transparency focus, the HTTP archive and the Chrome user experience report. We're going to talk about those tools a little bit later. I've been on this team for about a year and a half. Prior to that, within Google, I was working at YouTube, and I was on the team that helped make YouTube fast. So I was very much ingrained in web performance and web best practices. So it's really interesting to transition from working with one very big website and now as a developer relations advocate working with many websites or the web as a whole. I'm also a co-author of the book Using Web Page Test. It's a web performance tool that's also going to be covered a little bit later. So before we get into the details of Drupal performance, we have to answer a very important question. Why does web performance matter? Why does it matter that a web page loads in 5 seconds versus 10 seconds? Does anybody want to raise their hand and just throw out a guess or an answer for why web performance matters? Say again? Bounce backs. So it's like abandonment. If a site doesn't load quickly, people will leave. Anything else? Less conversions. It's true. So those two things pretty much form the basis of the next 6 slides, which is great. So you guys know your stuff. Web performance matters because it affects our users' experience. WPO Stats is a website maintained by the community. It's like a wiki. WPO standing for Web Performance Optimization. And it's full of case studies of performance correlating with business metrics like conversions, signups, ad revenue, things like that. And users are trying to tell you something when they buy more products or sign up for your services when the page loads more quickly. They want faster experiences. So for example, Pinterest measured their site performance improvement, and they were 40% faster, and they noticed 15% increase in SEO and conversion. This is one website's experience with it, but this website is filled with case studies just like this. The numbers might be a little bit different. So you might be wondering, what can I expect if I also want to improve performance on my website? Not everybody who improves performance by 40% is always going to see a 15% improvement to conversion rate. There are many variables behind that. So Google has a tool where you can plug in some of those variables depending on your website, and you can see the estimated revenue impact by improving performance. So this is just a hypothetical example, but as you fill in the information on top, you'll end up with a slider, and you can slide this around by some hypothetical speed up. So if you go from 1.6 seconds to 1.1 seconds, in US dollars, you can expect $181,000. Question?
Check the cloud.google.com on this calculator. I did, so quite interesting.
Oh, okay, so the suggestion is to go to cloud.google.com. So the thing is that you need to know certain things about the website, like the conversion rate, how many monthly visitors there are, and the average order or conversion value. The cool thing is that current speed is filled in for you thanks to a tool that we'll go through later. The magic behind this tool comes from Google Analytics. There's a model that's generated based on aggregated statistics about websites' conversion, and we can use that model to predict the revenue impact of performance. Generally, though, as performance improves, so does conversion. But I encourage everyone here, if you're going to run tests like this, or if you're going to try to improve performance, run an A/B test and determine for yourselves what that improvement is. And then when you're done with that, post that to WPO Stats so that everybody else can also see those interesting insights. So this tool, as you can tell from the dollar signs, is designed for business stakeholders. Show of hands, how many people here are on the development or engineering side of the house? Mostly everyone. Any people from the business side of the house? A few. So if you're from the development side, maybe you're not as motivated by dollars and cents as you are about just improving the user experience because you're convinced that performance is an important part of the user experience. But you might want to kick this up your management chain and say, check out this tool. Maybe you're not getting buy-in from your business stakeholders that performance is important. A tool like this could change their mind if you can show them the potential to be had. Another reason why performance matters is because of search. In January of this year, on the search blog, they said that site speed is going to become a ranking factor. And what they said specifically was really slow websites may be demoted, without defining exactly what slow means and what that demotion is. And it could be a small amount, but this is significant enough where people who cared a lot about SEO before now also need to be caring about web performance. Now they're the same thing, because it's all just user experience when it comes down to it. Another thing about search, the top stories carousel on Google search results page has been filled with AMP web pages. And Malte Ubel, the tech lead of AMP, recently said that they're going to be using objective performance metrics to determine eligibility into this carousel. So the other half of why performance matters is because of the users themselves. There's business metrics, and that's great when things are going well, but when users don't have good experiences, as you're going to see, things don't really go so well. So 60% of mobile connections worldwide are on 2G-like connections. So it's not necessarily that your websites are slow, it's that the user's connections to the websites are slow. You may optimize performance religiously, but your users might still have slow experiences on them. So it's still very important to keep this in mind. One thing you could do is degrade the experience for an even more lightweight experience for 2G users. So if users are on 2G at that 60% frequency, mobile users, it doesn't help that web pages are only getting heavier and heavier. This chart shows the global web trend of page weight over the last 8 years. And mobile pages aren't that much lighter than desktop. In fact, if you look at the trend, mobile and desktop are actually converging in page weight. And if anything, mobile is where the page weight matters the most. Mobile users tend to have paid data plans where if you exceed your plan, you either pay more for the data or you get throttled down. And in emerging markets, mobile users are on low-end devices. Maybe the tech infrastructure isn't as good. So if the median mobile web page is 1.3 megabytes and they're on 2G 60% of the time, how long is it going to take to load the median web page over 2G? If 2G is 70 kilobits per second, my math, check my math please, that should take around 2 minutes. That's crazy. We shouldn't be delivering 2-minute experiences to 60% of mobile users. So if users, when they're happy, buy more of your stuff when the page is fast, when the page is slow, they leave. And when they leave, they're not clicking on your call to action buttons, they're not seeing your ads, they're not reading your content. So this is bad news. There's no chance for them to sign up or see your ads or anything like that. This is important. So when the page takes more than 3 seconds to load, more than half of them abandon the page. I see some of you are taking pictures, so I'll leave this up a little bit longer and let that sink in. 53% of users abandon sites that take longer than 3 seconds to load. I have some more bad news, stats from the web. The median mobile load time is about 3 seconds. So in other words, the median is the 50th percentile. So half of mobile page loads are 3.1 seconds or slower. And if half of those users are abandoning, you can see where I'm going. So hopefully now everybody in this room understands why performance matters. How do we measure it? So we're going to look at a few different categories of tools that enable us to measure and optimize performance. lab versus field, personal versus public, and I'll try to explain the differences. I kind of like to do it in this quadrant type setup. So each tool answers the following questions differently. What are we measuring, and how are we measuring it? So first, we're going to look at lab tools. These are the tools that enable us to understand everything there is to know about how a website is built. Is it built on Drupal? How many bytes does it load? Does it use a CDN? And also diagnostic things like, are the images optimized? What could you do better? On the other side, we have field tools. These tell us how users are experiencing the website. And we can understand things like the device they used, the connection they were over, the performance of the page that they experienced, and of course the behavior, where they clicked around on the page. Personal tools enable us to understand particular websites. For example, you can run Chrome developer tools on your website and understand how it's built, what the DOM layout is. You can use Google Analytics to understand your personal website's real user experience. And of course, web page test. So let's look at that one first. And here I'm actually testing the Drupal.com website. The first thing that stands out is these grades at the top. These are the most inexcusable performance optimizations. So if you look here and there's anything red, you know that there's something that needs to be improved. But keep in mind that even if you get all A's here, that doesn't necessarily mean that there's no more work to do. Web page test also records metadata about the page load, like how long it took, the number and size of resources. But keep in mind, this is unique to the configuration of the test that was used, like the cache state, the connection speed, the geographic location. Changes in any of these variables are definitely going to affect the page load time and how many bytes are loaded. So while this might not be representative of your user's experience, if you keep these variables consistent and just test it over time, this will be a good monitoring service for you on your website so that you can see if anything does change, then you can go in and drill down and see what actually changed. And to do that, this chart is very, very helpful. This is the waterfall chart. It visualizes the network activity. It shows you what resources were loaded, when were they loaded, how long did they take to load, and of course the ordering of them, which is important. And this is really great for low-level debugging of why a web page is slow. Okay, switching gears to public field tools, Google Analytics. Everybody knows about this. I don't have to go into too much detail, but this is data from the field that tells us not how the web pages are built, but how the users experience them. For example, it can tell us how long users waited for a page to load, and it'll show the distribution of experiences from fast to slow. You can slice the data by user demographics, so you can see like if users from one geographic region have slower experiences than another. And you can understand the user journey. What are the entry pages? Where do the users go next? What UI on the pages do they interact with? And what's great is that you can use this data to calibrate your lab tools. So on web page test, you could use this data to say, I should test it on 3G from this particular country and starting on this page. You could even calibrate your web page test to go from a landing page into a secondary page and see the performance of that secondary page. Okay, so those are the personal tools. And now we're going to get into the meat of this talk, which are the public tools. And these are the web transparency tools that I work on. So to understand the web ecosystem as a whole, we need tools that can scale up to hundreds of thousands or millions of samples of websites. And these are the tools that we're going to use to understand the Drupal ecosystem. In a chart earlier, we saw that the median page weight is about like 1.2 megabytes, and this comes from HTTP Archive. It's a public website of high-level stats and trends about the web. And people use it for all kinds of things, all kinds of research. For example, sobering observations about the state of the web. The average web page size exceeded the size of the game Doom, and this was 3 years ago. So imagine where we are today. People also use it for academic research. It appears as citations in journals like ACM, IEEE. Standards bodies use it for deprecation research. If they want to deprecate an API and they want to know where and how is it being used, they can query the HTTP archive to understand that type of usage. So it's very, very powerful. Here's how it works. It tests 1.3 million websites twice a month. And note that it's just the homepage, not the entire website. And it runs on 400 instances of web page test. It needs that many to run in 2 weeks' time. Raw data is made available for analysis in Google Cloud on top of BigQuery and cloud storage. So you can access this data and run your own analysis. But we have curated reports, like the page weight over time, surfaced at httparchive.org. Next, a public field tool is Chrome User Experience Report. This tool is about a year old. It's a collection of real user performance data from millions of websites. The data pipeline starts with the users in the Chrome browser who opt into usage statistics collection. And we collect the device that they're on, for example, if it's a phone, desktop, or tablet, how fast their network is. And it's not necessarily this user's on Wi-Fi, it's the effective connection type. So right now on conference Wi-Fi, I could be getting something like 3G speeds. So it would note the effective connection type. It also notes the country that they're located in and how fast the web pages are. That data is sanitized and anonymized, and so we can get a distribution of performance for an entire origin. And an origin is just the protocol like HTTPS, example.com. Not necessarily the leaf pages after that. And we also exclude web pages with too few users, so we don't have any uniquely identifiable information in the data set, or websites that aren't public. If they don't want to be crawled by the Google bot indexer, then we don't include them. Finally, the data is published for analysis, also on Google BigQuery. And it's also available in other tools like PageSpeed Insights. So if you look at an analysis of how your web page performs, it will tell you your Chrome User Experience Report data. It'll give you a little distribution of fast, average, and slow, and we can see how that looks a little bit later. So the metrics that are covered, there are 5 of them, and here we have the core 4 metrics. First paint, first contentful paint, DOM content loaded, and onload. So you can see they measure different parts of the page load time. First paint is just when something appears on screen. In this case, it's a background image. It's not very helpful. The first contentful paint is something that indicates to the user that the page is loading, we're showing you something useful. DOM content loaded is when the markup appears. You don't necessarily have images yet. Those only appear at the onload time. Lazy loaded things happen after onload. The 5th metric is first input delay. This is a very new experimental metric. And what this measures is the time from when a user first interacts with a website, for example, clicking a button, to the time that the website responds to that interaction. Now, we expect this to be instantaneous. If we have to put a number on it, less than 100 milliseconds is instantaneous. But if you have too much JavaScript on your website and it's just chugging and chugging along, or if the device itself is slow or busy with other processes, you can imagine that this delay could be very long. Okay. So we've established the foundation of why we should care about performance and how we're going to measure it. So how does Drupal perform? We're going to start by analyzing the data in HTTP archive. Like I said, it tests over 1 million websites. To know which ones are built with Drupal, we use a tool called Wapalizer. It detects over 1,000 web technologies, and it's integrated with web page test. So because HTTP archive has web page test upstream, we get this data for free. So I know I just said 1 million websites, but we changed over from 500,000 to 1.3 million relatively recently. So in order to get a good before and after, like you'll see in a second, I'm actually using the data from June 15th, when we had 461,000 websites. And of those 461,000, we found 15,000 Drupal websites. The math works out to be about 3%, which is nice because that's the anecdata that we have about Drupal's market share. So we can reasonably trust this data to be representative. You can access the data at drupal.httparchive.org. This is a new feature that we recently added where we have a lens onto the HTTP archive data. So if you add drupal.httparchive.org, we also have wordpress.httparchive.org. There's also a UI on the website if you don't access it directly through here. But you can just narrow down onto that specific platform. And what you'll see is data like this. So for example, we have a page weight report. You can find out things like how heavy is the median mobile website built with Drupal specifically. How many images does the median Drupal website load? And how have these numbers changed over the past year? So you'll see increases by certain percentages, that's year over year. You could also drill down into any of these metrics to see a graph of that median changing over time. You can drill down into a particular date to explore the distribution of all 15,000 websites. Something that looks like this. So the median Drupal page weight is 2.2 megabytes, but you can see that there's a mode around 1.2 megabytes. This is a log normal distribution, meaning things kind of are skewed on the fast end, but there's a very long tail into the seconds and tens of seconds. So I'm going to be going through about 10 metrics in the next few slides. So here's a helpful legend to help you understand what I'm trying to say. On the top, I'm going to tell you the metric that we're measuring. The value is obviously going to be front and center. The difference compared to the rest of the web. So if I say Drupal is about 2 megabytes is the median page weight, then I'll give you the difference from Drupal to the rest of the web. And we're looking specifically at desktop websites. We've been talking about mobile earlier, but we can do the same exact analysis. All the data is separated by desktop and mobile on the website. So the page weight is the total number of bytes loaded by the page. And this is on a cold cache, nothing is cached. And if the content is gzipped, then we count the gzipped bytes. So the median page weight for Drupal is about 2.2 megabytes. It's almost 500K bigger than the median web page. So Drupal sites load a lot more stuff. That's the last thing is, the takeaway is right at the bottom. If you don't grok the stats, you can just look at the takeaway. So 0.5 meg more on Drupal websites. We're going to drill down into different resources later to try to figure out where this comes from. Year over year, actually this isn't year over year, we're looking at data since January 2016 when we were first able to measure, is this a Drupal website or not? Drupal sites have grown in weight by 22%. This is a slightly faster rate of growth than the rest of the web. So something about Drupal is causing it to grow at a faster rate. So we can look at specific resources like CSS. 66K, that seems reasonable to me. It's only 13K larger than the rest of the web. It's not a lot more CSS. Sounds reasonable. The rate of growth is similar to the total page weight, about 20-something%. But the good news is that the rate of growth is slower than the rest of the web. The rest of the web is growing more CSS more quickly. JavaScript. When I was doing this analysis, I was like, oh, it's going to be JavaScript, I know it. 23 JavaScript requests is the median for a Drupal website. It's only 4 requests more. Not too much, not very significant. There's about 400 kilobytes of JavaScript on the median Drupal website. But it's only about 30K larger. Slightly heavier, yes, but I don't see 30 extra kilobytes causing too much trouble. The growth since 2016, we're still in that 20% neighborhood, but it's a little bit more slowly. So I wouldn't pin it on JavaScript. Fun fact, when I did this analysis for WordPress, it was JavaScript. So images. Median Drupal website has 42 images, up from 38 on the median website on the web. Slightly more. Median image weight, 1,225.2 kilobytes, about 360K larger. So I think this is the area for the most improvement of Drupal. And to confirm this, I looked at another stat. The median, I'm sorry, we're still looking at change over time. It's pretty similar as before. But the median image savings, you could save about 50K on your images if you were to optimize them, take full advantage of image optimization. About 30K more bytes could be saved on Drupal. So we want this number to be as low as possible. 0 byte savings is the ideal here. So we're not taking full advantage of image optimization. I don't know if this is a module issue or if the design department is giving the developers unoptimized images. Maybe they're too big, maybe they're not responsive. This is an area to look into. So this is the state of performance in the HTTP archive. This is going to get really interesting now. So we can look at real user performance in the Chrome UX report, or Crux, as I like to say sometimes. Crux has about 1 million websites in the data set, and the August data set was just released yesterday. And there's about 34,000 known Drupal websites in there, which still pretty much correlates with the 3% estimation. So here we see first paint. And the way to read this chart is we want to see as much of this distribution in the fast bucket as possible. Fast, average, and slow are separated by thresholds of 1 second and 3 seconds. So what this is telling us is that Drupal websites have a first paint experience less than 1 second about 38% of the time. Another way of saying it, looking at the other end, is about 18% of the time, Drupal websites paint slower than 3 seconds. Compared to the global average first paint, it's slightly worse. Close, but slightly worse. Slightly slower. Same thing for first contentful paint. Remember, the distinction here is just that the content is useful to the user. Same story. But things get interesting when we look at DOM content loaded. Drupal websites tend to have a slightly higher cumulative distribution of fast DOM content loaded experiences. I have to be very careful with my wording than to say Drupal is faster, because it's a little bit more nuanced than that. On-load time, similar to DCL, where slightly more fast experiences. And first input delay. So this is great. Most of the web has 85% fast. FID is the acronym for that. And Drupal is even better, 88%. So you might be thinking, okay, you're comparing a CMS to the rest of the web. CMSs are special. So one thing I did was I compared all of the CMSs together. And you could see how they compare against each other. These are also sorted by CMS popularity. So WordPress, as we know, is #1 CMS by popularity, 30%. And you'll notice that WordPress has a smaller density of fast, this is FCP, than Drupal. All the way at the other end, Wix has about 5% fast FCP. And the funny thing is I tweeted this out yesterday, and I just thought it's a cool chart, let's share it with people. And it was actually picked up by an SEO journal. And people are going crazy, like, WordPress versus Wix, look at the differences and everything. And so something that's really great that came out of that was somebody from Wix reached out to me and was like, I want to improve our performance. What can I do? How can I better understand this data set? And I love that. That's the spirit of web transparency, is using this data to understand how users are experiencing the web and then doing something about it and optimizing it. But the next 2 slides are my favorite, as interesting as that is. This Drupal band here, it just has 3 colors, and the only information we're getting from it is the width of all these colors. We're trying to roll up the entire Drupal ecosystem into 1 bar with 3 colors. It's a little bit more nuanced than that. So of all 34,000 Drupal websites, we can take those little bars and plot 1 bar for each website. Everybody who raised your hand when I said, are you a developer, your websites are somewhere in this distribution. The question is, which end of it? And I want you to feel a little bit of anxiety when I ask that, because if you're on that end, your users are having poor experiences. Maybe those are the users that are abandoning your website and not signing up. So this is FCP, super interesting curve here, but I love this one for FID. We know that 80-something% of FID is fast, but it's really cool to see how it changes. And when you reach the end, I've never seen a pattern like this where fast drops down to 0 and then average takes over. Normally they kind of go together. Fast and average diminish and then slow takes over. Really cool. Again, which one is your website? Do you have very bad interactivity and responsiveness on your websites? To help answer that, you can explore your particular website's user experience data by going to g.co/ChromeUX-. This enables you to generate a custom site report of your user experience data. Now, hopefully this isn't anything new to you, because you could have Google Analytics on your website. Hopefully, or even if not GA, you have another RUM solution, Real User Monitoring, and you can collect all this data. If you're not, don't worry. We have historical data, like I mentioned, it's about a year old. This is a real Drupal website. I pulled it out knowing that it had slow FID. So you could see how the first contentful paint evolves over time, what its distribution looks like, but it has more than that. You could see the distribution of user devices between phone, desktop, and tablet. It's really interesting to see this website has mostly phone users or user experiences. And no matter which website I look at, tablet is always less than 5%. It's not a very popular device. And like I mentioned, the effective connection type, you can see on a particular website how much are 4G effectively, what percent are offline. This is super important. If you were in Barb's talk earlier about PWAs, if your PWA has a large percentage of offline usage, you can tell that's a significant part of your user experience, and you need to invest in that more heavily. Luckily, this one doesn't have so much slow 2G, but the fact that the users are on predominantly 4G-like connections, but the experience is so slow, this tells me it's the website itself that is slow. It's not the user's connections to that website. Okay. So we've seen the state of how Drupal performs. How do we improve it? It's a tough question to answer, but I have a few ideas. We can't improve what we don't measure. We need to monitor the performance of the ecosystem, not just of Drupal, but the web as a whole. I take this as my responsibility. I run these web transparency tools, HTTP Archive, Chrome UX Report. These are public tools, free to use. We can use it to track the improvements in the ecosystem and hopefully flagging any regressions and fixing them. But it's also up to site owners like you to monitor your own performance and make improvements. There's an acronym MOM, where it stands for Measure, Optimize, and Monitor. So we need to monitor the performance. We need to celebrate performance. Incorporate it into your culture. If somebody on your team is saying, let's add another image carousel to the homepage, I want somebody to raise their hand in that room and say, okay, but how fast is that? What are the performance implications of adding another carousel? And if it's slower, do an A/B test or something, and then throw out the carousel. Celebrate success studies. WPO Stats is full of case studies of successful performance improvements. Publish your own case studies of performance improving conversions or anything else. That will help convince other people to care about performance as well. We need to work with developers. We need more well-lit paths for making fast websites. It should be the default experience to make a fast website. You should have to try to make your website slower by adding 3 different carousels. And we need to incentivize performance. I don't know how we're going to do that, but I think we need to start exploring different ways to do this. For example, if there are themes where one is faster than the other, I think it would be really great if we can identify which ones are the fast themes. So when somebody's shopping around for a theme, they can pick the faster one. That could be part of their decision-making process, not just how flashy does it look. How does it affect the users? Because remember, performance is just one part of the user experience. I can come back next year and give a talk on the state of Drupal blank, localization, accessibility. So, obligatory thank you slide to our sponsors. Obligatory be a Drupal contributor on Friday. Here are links to most of the resources, and most importantly, the link to the slides is at the bottom, bit.ly/DrupalPerf 2018. You'll get links to everything. Also, here's my contact information if you want to reach out to me. I'm on Twitter all the time, so if you have any questions, feel free to reach out. Thank you. We have some time for questions. Does anybody have a question?
At the end, you have talked about incentivize developers, but I think the most problem is to incentivize customers because they don't want to pay for a lot of enhancement, and I think we have to find a lot of arguments to convince them. So I think maybe it's sometimes more important because I've worked with a lot of developers, and I was just before to change my job. But developers want mostly the best and want to learn, but the problem is always, okay, we don't have time, the customer didn't pay for that, so I think it's most important. So, yeah.
Thank you for the comment. So, how do we convince the customers to invest in performance? So, I'll just fall back to this slide. Performance is part of the user experience. If customers want a secure website and they're willing to pay for a secure website, why aren't they willing to pay for a fast website? And there's, I would say, a stronger correlation between performance and metrics, business metrics like revenue. There isn't really a sliding scale of security on a website where a user's like, this website's more secure, I think I'm going to sign up for this service now. But if the website is slower, there is that sliding scale where they will abandon the website if it reaches a certain point of slowness. So I think one of that first slides about the revenue impact calculator showed the clients or customers, if you invest in performance, you'll get it back. It's an investment. If you allow the developers to spend the time to focus on it, making the website fast, they're going to see that money back in the form of happier users converting in whichever way that website monetizes. Thank you.
By looking at the image weights of Drupal websites, would you suggest putting an image optimization tool into core? Because right now it's in the contrib ecosphere, and as far as I know, there are lots of sites out there which don't use image optimization.
Are you asking for my opinion about how it should be solved?
Whether your suggestion would be, or your recommendation would be, to put this feature of image optimization into core, so the default option wouldn't be to serve out slow images or badly optimized images.
Yes, I would agree with that. That having unoptimized images should be impossible. You shouldn't be able to serve an image beyond the size that you're going to serve it. I think it should be built into the platform where you can have WebP to supported browsers, serving the most optimal image and having responsivity built into that as well. How we do that, I leave that to you all.
Just as a comment from experience, I think Drupal agencies might not be that focused around site speed or page load times, so that might be one factor. I think the Drupal hosting companies could do a better job at kind of providing those services. And then there's maybe SEO focused companies who really look at the times and so on, but there may be a disconnect between that point of view and then the agencies. So I think kind of everyone needs to pay more attention to this, basically.
Yep. Any other questions? One more here.
I know it's a relatively new metric, the first input delay,
Right.
or what's it called? But how does that take into account which kind of website that you visit? Because, for example, if I visit the Google homepage, or people will relatively quickly start using it. But if I land on a news page, there might be some interesting news articles already in the viewport. So it might take 2 or 3 seconds before I skim through the content and then start using the website. How do you take that into account? I know it's probably not possible or not easy, but...
Well, you're entirely right that it's context dependent. And the metric does not take it into account of what kind of website. When I was analyzing first input delay, I was wondering why is it so fast in most of these cases. I looked at the sites with the best FID values, like 100%. And I visited the sites myself, and they were really slow websites, which was counterintuitive. But I think what happened was the users know the website is slow, so they don't try to interact with it. Maybe it has a very compelling spinner. It tells them when things are going to be ready, so they just sit there waiting, and then the spinner goes away, and then they start tapping on things. So it could be a combination of the type of website, how they handle their main thread, which is the main blocker of interactivity. It could be how the website actually responds to that user input that may actually affect whether the metric itself looks good or bad, which is why when we look at user experience, we can't just look at one metric. It's actually the combination of all of them. So the two that I like to focus on are FCP and FID. And you won't usually find a website that has fast FID and they are slow and they also have fast FCP. Like they usually align quite well.
Thank you.
Thank you. Question in the back.
Hi. So regarding the metrics, I was wondering whether you're not afraid that people are gaming those metrics, because in my experience, a lot of people will make the site quick to load until a certain point, and after that comes all the bloat. So very famously, for example, the Google AMP site, I don't know whether that was fixed, basically loaded content infinitely because it didn't use the cached video they had on there. They had such a spinner, as you mentioned, but it loaded it over and over again. Or internet.org by Facebook also was really focused on bloat removal, but they had the same problem. They had, I don't know, 20 megabyte page or so. But they were great according to those metrics that you showed. Do you also consider complete loading of the site? Because that also takes your phone battery, that takes your bandwidth, and so on.
So complete loading most closely aligns with the onload metric. That's like when all of the images and things have loaded. Of course, things could happen after the onload event. People can trigger lazy loading if the user interacts with the site, like scrolling, you might load in new content. If the site has an auto-playing video, then all of those video bytes are just going to be constantly streaming down. So when is the end of that page load? It's not as clear. To the point about gamifying the metrics, people are probably going to do that. Once you incentivize performance by saying if your website is fast, you'll have better search incentives, then yeah, I can imagine people will do that, but they're only putting their users at a disadvantage. If you, for example, have like a really fast first paint, if you like send down a screenshot of your loaded web page and then wait for the page to dynamically load in, like it's gonna look done, but users are gonna be pissed off. They're not gonna be able to click on anything. And hopefully with metrics like FID, we're going to be able to kind of counteract that.
But aren't you also using those metrics in SEO? So you wouldn't punish those websites in ranking, although they would deserve to get punished. So the people get away with such design. So there's no incentive to fix it.
So right now we're only punishing, not really punishing, the speed, how should I say it? They're calling it the demotion. Would only affect the slowest websites. So if somebody is gaming the system to appear fast, we won't necessarily give them an advantage over a site of the same speed or of the same exact content. Another question?
What is your opinion of the page speed module?
Page speed module?
Yeah, it's a module for Apache and Nginx. It's
Okay.
by Google, isn't it? Or
Yes, I've actually used this module. I think it's deprecated. So my opinion is, if you're using it, continue to use it, but phase it out. Page speed module has a lot of the optimizations that are recommended by Page Speed Insights. It's a service where you can give it your URL, and it will tell you how to optimize your web page. And it will also give you your Chrome user experience report data as well. My opinion is, if it makes your website faster, do it. If it's deprecated and it still works, stay using it. That's fine with me. But have a plan to migrate away from it and implement some of the newer best practices. It's not doing everything that we recommend. But I've used it on my personal site, and it's a good tool. All right, thank you again.